All right, good morning. I'm Tom Steenbergen, and I'm leading the ML platform efforts at Picnic. And today I'm going to talk about prediction archiving, what it is, and how we are doing it at Picnic, and what the key learnings were for us when implementing the solution that we came up with. But before I start with that, does anyone actually know who or what Picnic is? Oh, there are a few actually. Surprised, but nice. Picnic is a online supermarket based in Amsterdam. We're operating in the Netherlands, Germany, and in France. And our mission is to make grocery shopping simple, fun, and affordable. And we do this by being mobile only, by delivering the groceries to the customer's door in very precise time windows, and using sustainable electric vehicles. And we'd like to see ourselves as tech's answer to groceries. So we are in direct contact with our producers to make sure that we get the freshest goods to our customers, and to basically orchestrate this whole supply chain. We have a large set of in-house built systems that were specifically designed for Picnic's operations. So from the store app that the customers use to order groceries, all the way to the various apps and systems that the warehousing teams and the delivery teams use to get the groceries to the customer's door. All of these systems produce a lot of data, as you can imagine. So we have a fantastic data engineering team at Picnic that makes sure to relate and model all of these data sources into our central data warehouse, Snowflake. And from there, the rest of the company can make data-driven decisions. One of the teams is the data science team. And the data science team at Picnic is a central data science team that not only models and wrangles data, but actually does the whole machine learning lifecycle from ideation up until productionization, and after productionizing, also making sure that it actually keeps up and running. And all of these models, they feed back into these processes that you see on the top and the systems that supports these processes. So we have recommender systems that make sure that the ranking is personalized for each customer in the app. We have various demand forecasting models that determine how much stock we should keep in the warehouses. And we have models that predict how much time we exactly need for a customer to make sure that our planning is as efficient as possible. And while we are growing and while the company becomes more mature, we notice that, well, our machine learning models, they have more and more impact on operations. And when things go wrong, then they can go wrong with quite a big price tag. So we want to make sure that whatever we're feeding back into those systems, we have a really good view of that, and not just like logging them and and you need to go through 3 different systems to figure out what your model outputted. We wanted to come up with a nicer solution that not only we could use, but also our analysts, to figure out what kind of predictions were actually leveraged in our supply chain. So that is where the topic of this talk comes in. So prediction archiving, how we're doing at the Picnic. But before we get to that, maybe first, what is it actually and why should we care? So prediction archiving is basically all about storing the predictions of your machine learning models in a standardized way, in a central place where they're easily accessible for the long term for various purposes. 3 main purposes in our opinion. First of all, monitoring. So really looking at the past few weeks and building on top of that observability and alerting to make sure that whenever you are detecting model drift or your model is behaving erratically, you actually get an alert and the maintainers of that machine learning model can do something about that. The second is model development, so really looking at the longer term. So for example, the year-to-date performance of the certain machine learning model. Are there some systematic errors that we're seeing, and can that give us ideas for improvements to get to a better model accuracy? The last one, and definitely not the least, is governance. So can we go back in time and exactly see at what time a model made what kind of prediction, and what data was actually used to get to that prediction. All right, because even a few years from now, a customer can ask like, hey, why was this decision by the system made at that point in time? And we want to be able to go back and actually debug and see what happened there. Also for internal stakeholders, this can be a very valuable tool because sometimes it can be hard to drive adoption for a machine learning model. And having this kind of like transparency to what your model is actually doing and how that is impacting all the systems within your tech landscape, that can really help to drive forward the discussion. So if we're talking about predictions, we at Picnic have two different types of serving systems. First of all, it's basically your like offline or batch processing job that generates predictions in bulk. So we have various Python cron jobs scheduled on Kubernetes that produce, according to some regular schedule, a large amount of predictions. And on the other hand, we have Python web service also scheduled on our deployed on our Kubernetes cluster, which are more like the online inference use cases that the industry talks about, where we basically serve one or a few predictions upon request. Both produce predictions, but both have different behavior and different requirements. So the data volume is different, and also in terms of latency, the requirements are very different for those two types of serving systems. But in the end, they produce predictions. And in the case of Picnic, they usually look something like this on the right hand of the screen. So besides the actual value of the prediction, you want to, of course, have the exact timestamp on when the prediction was created. You want to have some identifier to make sure you can always like link that prediction back to the entity that you were making a prediction for. So you can always link it to like the ground truth value of the prediction afterwards. The artifact ID is a very important one because we want to be able to link back a prediction to the exact binary, the model object that we stored in our model registry. And of course, features, input data, and any other metadata that you might want to add to the prediction. Because in most of our cases, we don't just deliver and deploy a model, but we actually package it in, proper software and have some business logic around that as well. And around that business logic, there's oftentimes some metadata that you might want to include when you're logging your prediction. All right, so now that we know why we should care about prediction archiving, what kind of serving systems at least we have at Picnic, but I think can be quite similar to many of your companies. And now that we know what a prediction in general looks like, let's talk a bit about what it is that we build. So this is, in essence, the high-level overview of what we built. So on the left-hand side, you see the various serving systems that we have. So both the batch processing jobs as well as the real-time inference servers. And we recognize we need different pipelines to make sure we get all of that data eventually in Snowflake in our analytical data warehouse. And from there, we have a post-processing jobs that make sure that we are preparing all of that raw prediction data for easy access and analysis by the hundreds of analysts that we have at Picnic. So let's dive into this a bit further, component by component. So first of all, about the Python cron jobs, the batch processing jobs, we are leveraging Snowpipe here. So Snowpipe is a Snowflake object, which is basically wrapped around a copy into statement for those familiar with SQL. And that is a very efficient method to copy large amounts of data from a file into a Snowflake table. This Snowpipe, you can link that to a staging area, and there are different kinds of staging areas. But the one that we're using is a AWS street bucket, and it will then be notified whenever a new file gets uploaded to that S3 bucket. So every time a new file upload happens, the Snowpipe makes sure that all of that prediction data contained in that file immediately gets piped through to a dedicated table in Snowflake. But because of latency requirements and different data volumes, we figured this is not the right solution for our real-time web services. So for our real-time web services, we are leveraging Kafka because of the times the predictions that they output, they're like just a few or maybe just one prediction, and they have SLAs that we got to meet. So we're using Kafka here, and we are using that in combination with the Snowflake sync connector, and that basically makes sure that we can map a Kafka topic to a dedicated table in Snowflake. And the nice thing about this is as well that it's fault tolerant. So whenever we, by accident, emit messages that do not adhere to the schema, then the whole pipeline doesn't break. It just continues running. And we can always later on fix the events that were malformed afterwards. One thing that's nice to add here as well is that we can get away here with a single Kafka topic because we have a standardized schema of what a prediction should look like, and we only have one consumer here, which is the analytical data warehouse. And that is nice because then we don't need to create new Kafka topics and configure new sync connectors for each and every use case that we add. Instead, we can just use the same topic for all of our use cases. All right. Then after both types of serving systems get the data into Snowflake, then we need to combine the data, and we have a helper cron job for that we built the prediction loader. And besides combining that data, we also make sure that it is actually doing some validations, and not just like schema checks, but actually also validations like, okay, given this artifact ID that's like logged with this prediction, can we actually find an artifact in our model registry with that exact ID? And if not, we want to make sure we are alerting the right people to make sure that they are fixing their prediction export and the predictions that have been exported so far. After that, we can easily create secured views on top that combines that prediction data with other data that we have in the data warehouse or with the ground truth values, for example, and prepare secured views for analysts to build dashboards on top. So a dashboarding tool that we internally use at Picnic is Tableau. That's what the analysts are familiar with, and that integrates nicely with Snowflake as well. So that is the solution, but that's of course not all of it, because after you create a nice fancy tool for your data scientists, the next step is of course making sure that they are actually going to adopt it and use it, and preferably use it correctly. So second part is trying to promote usage, because we know that you can't force people to use your tool correctly. So what we did is we inner-sourced a few clients, high-level clients that were very easy to use for all of the data scientists to make sure that all of our predictions gets logged into our data warehouse in a standardized way. So to zoom in a bit on the left screenshot, so this is, for example, the high-level client that we created for our real-time web services. So we make sure that we are also exposing like a Kafka config object, which is a very high-level config that only requires minimal parameters. And that is nice because if you ever work with Kafka, you know that if you're creating like a producer, there's like a load of configurations that you can tweak with. So we made sure that we are actually setting all of these sensible defaults that we want to promote within Picnic, such that the developer or the data scientist doesn't really need to think about it. After having created this config, you can just like plug that into this client, and you can use the very simple send method to log your prediction. And if you forgot what the schema looks like, we also like include a type dictionary to make sure that people know what kind of fields to include with their prediction. Similarly, for the S3 file upload pipeline, we have a different client. Again, minimal configuration, and just a very simple send method that people can use to make sure that all of the predictions end up into our data warehouse. So what were our key takeaways when we started on this project? Because we, of course, didn't figure this out from day zero. We've deployed multiple models, of which we, in the end, thought, well, maybe we should have exported that kind of data as well with that prediction, or hey, maybe we should have included this field. So, well, these are our learnings. So first of all, of course, prediction archiving is crucial for the reasons I mentioned earlier. So for monitoring, but also for longer-term model development, and most importantly for governance, to make sure you can always go back and see what kind of predictions you actually output it in the various other systems in your tech landscape. Also, it's important to use the right tool for the job, because you have different serving systems, they have different SLAs, they have different behavior, and you want to make sure that the solution you build actually is able to handle that. And this is something that I probably don't need to tell you, but standardization is key. So you really want to make sure that you keep it as simple as possible for your data scientists, for your developers, or whoever is using your platform, and reduce the complexity of using your platform. And another way to do that is to simplify migration as much as possible. Because introducing a new tool and having to migrate all of your 10 models to it is never fun. So better to make sure that adoption is as easy as possible. And a great way to do that for us was by inner sourcing the clients, and to also make sure that we, not just now, but also in a few years' time, we make sure that the tool we build is actually usable for the various use cases that will come up in the future. That was all I had, but would like to take this opportunity also to thank the data science team, analytics platform team, and the data engineering team at Picnic, because of course it was not a one-man effort, but a team effort. And if you think that we are building cool stuff, then please keep an eye out on our blog, because we regularly post some nice blog posts there to share what we've built. And even better, if you want to help us build cool stuff, then check out our career page, because we're hiring. Thank you, everyone.